Okay, before we work on this problem, question 8, I just want to show you the mark allocation. This is 6 marks. There's something very important I want to explain. If you have, let's say, you have a graph like this, right? So, on this graph, let's say that you have a tangent. Remember, a tangent, it's a line, it's a straight line that touches the graph at one point. So, this point here, the point of contact between your graph and a tangent, it's let's say it's in the form of x and y. So let's call this x value A, let's call the y value B. So what I need you guys to understand is that when you are working on this problem, what I need you to do, what I need you to note is that if you find the derivative of f at x, when you have the derivative, you substitute the value of the x coordinate of that point of contact. The answer that you get is your gradient of the straight line. This is what you need to understand in order for you to answer this question. So what I'm trying to tell you is that first thing first, you need to find the derivative of this graph. So but now we can't work with this type with a question like this. We need to put it in standard form. Remember, when you have fractions, you need to move them. So I can write this as 2x plus 1 over 2. The x will be to the power minus 1. So I need it in that form so that it will be easy for us to find the derivative. Therefore, if it is in that form, f prime of x will be what? F prime of x, the derivative of this 2x is the same as 2. I think now you know, because remember, this is just revision. You already know how to find the derivative. So now the derivative of 1 over 2x to the power minus 1, it will be negative 1 over 2 x to the power negative 2. So just for in case if you don't understand how we got to that, remember, if I have x to the n, the derivative of this, we take the exponent, we bring it down, which is n x. Therefore, on top we do what? We subtract 1. This is what I applied here. I take the minus 1, I bring it down. Therefore, I still have 1 over 2x. On top, I'm going to minus 1. So this is your what? This is your f prime. Remember, what I just explained is that you take the x coordinate of the point. They say determine the equation of the tangent to the curve f. So at the point, I need you to take, this is your x, this is your y. So on your f prime, you need to substitute where there's x, you need to put that x coordinate to find the gradient of that tangent. So this is what you have, and if you put this on the calculator, this will give you 3 over 2. So now that you have f prime, it's easy for you to find the equation of the gradient. So if you still remember, the equation of the tangent, it's a straight line like this. So already we know the gradient, which is 3 over 2 plus 3 over 2x plus c. We need to use this point to find the value of c. So where there's y, we can put minus 5 over 2. It's equal to 3 over 2. Where there's x, we put minus 1. Now is the safe time to solve for c. So when you solve for c, therefore c will be what? Remember, the 3 over 2, it will be negative because we are multiplying that by a negative number. So this will be minus 5 over 2. So it will come on the other side to be positive 3 over 2. You need to add those two. And tell me what you get. Therefore, you'll find that the value of c is just minus 1. If the value of c is minus 1, this tells you that the final graph, I'm very sorry I don't have space, but the final graph is y is equal to 3 over 2 x minus 1. So the the most important thing is for you to first find the derivative. When you have the derivative, you take this x coordinate of the point of contact, you substitute it on the derivative to find your gradient. And that's it for this problem. You have your 6 marks. That's easy 6 marks. So if you can follow all these steps, you're going to collect all the 6 marks.